Our first assignment is P5-16. The book will have a couple of instructions to go with it. So we will create an assembly drawing. We will create part drawings as well. Exploded isometric drawing with assembly numbers, parts list. Animation will be optional, and the list sometimes we'll get to those. Sometimes we'll ignore them. So the more complicated ones will be an optional if you have time to complete those functions. So when we're looking at this and the movement of the crank, the coupler, I think that meant to be debossed letters, so it's going to go in, and emboss is out, and then there are for just standard engraving, we would just lay the sketch on there so that the CNC tool could follow those outlines. So looking at this geometry from a manufacturing standpoint, the shape, if we stay more rectangular, the shape is that kind of L shape, and I need to turn my drawing tools on so we can see if this is going to work. So when I look at these parts, you kind of are going to get into a mode where you will go with your first instincts. And my first instinct is this L shape over on the side. And if I can draw the lines, my touchscreen's sort of working. All right, close enough. And by extruding that out, whether this becomes the right plane or we draw it from this side, I'm not so concerned about orientation. We are going to locate one part of this to the origin. All right, so one of those corners is probably going to be the best choice there. If we have other choices, we could draw a top view and then add this geometry onto it to create that shape. Whoops. All right, well, having too much fun with the sketching tools, and then build that up. Problem is that we're going to end up with the multiple features. Looking at the dimensions, the 8, well, I guess I need to go to freehand there. The 8 and the 10, if those were the same, we could possibly do that as a thin feature and just draw the L shape and extrude it out and tell the SolidWorks what the thickness is. So again, there's going to be some terminology. There's going to be a lot of little nuance things that are going to show up in these drawings. That for our first go around, getting into the mix, creating the geometry, adding the dimensions is the priority. Making it perfect comes later. Looking at the material, the 2024 T4 aluminum, not necessarily a standard aluminum, probably available, but yeah, would not be my first choice. 6061 is going to be just the all-purpose. If you were bending this, but since it's not the same thicknesses with the 8 and the 10, not much point in trying to bend it. And the let's see, radius of 3 is really too tight for something like that. So we're going to either be machining this or we're going to be buying an architectural structural L shape and then still have to do milling. So might as well just be making this out of a square and then machining that notch out of it. So there is going to be some machine processes that we're going to have to deal with. The radius of 12, and assuming that it's radius of 12 here, not called out, and missing dimensions. If the rule is if there's a missing dimension for our purposes, you get to decide what that is. The assumption would be that the radius of 12, two places, would also be at those two places as well. So let's clear that out. We have a hole pattern. We can do that as a linear pattern inside of the sketch, or we can do that as a feature pattern outside of the sketch. Right, so we'll probably take a look at both of those, and then this geometry will settle. All right, so that's our first. Oops, let's get out of the draw. Okay, so if we scroll down to the next part, we have another exploded view. We will be making the exploded view, and the exploded view lives in the assembly. There are going to be 3 of these, so we will do the file save as. So really what it's telling us here is the 3 lengths for the 3 different part numbers, and that will be fairly straightforward on our geometry. The short pin, whenever we see the revolves, again we're going to take that quarter section and our center line, and that's going to be our geometry revolved around. And then we get to the long log pin, and basically the same thing. So that gives us all of our shapes, and we don't necessarily have to do these as revolves. We could build those up like wedding cakes. It's just we get the most bang for our buck for putting them into revolves. So taking a look at the assembly and the geometry that we're dealing with, you can kind of start to formulate those strategies, make some quick decisions, and the difference between a purely conceptual model versus, hey, I'm having you reproduce this. In the conceptual, you're already going to start to develop images, and usually there's going to be some rough sketching, and we're going to try and use the tools that we have available to get as much information. But there's always something on the conceptual side that the unforeseen, the overlooked, the didn't anticipate that, or anticipated it but didn't know exactly where it was going to go. So it's an evolving, iterative process. This is not it does not become a perfect model in the first go around, and sometimes they don't ever become perfect models. We have to settle for good enough.